Hey Year 12, this next one is on 12B, and there are a couple of exercises for this one as well. It goes from 12B.1 to B.4, so I might just do the first half for you. So this is where we're going to be looking at now geometric operations with vectors. So, adding, multiplying, subtracting, etc. In the past we have done things where we've worked out the displacement by using Pythagoras' theorem or trigonometry. So in this example above, you can see if I wanted to find that x kilometers here, we would do Pythagoras, or we would use like SOHCAHTOA. But now we can do geometric vector addition. So if I have this vector here, PQ, what we do is we line up the base of the arrow to the head of the arrow. So there's that PQ, and then the next vector I'm allowed to place here, and then so the tip of this arrow is now at the tail end of the next one, and so the pink and the yellow, if I add it together, it actually gives me the one that I've highlighted in green there. So here we've got vector PQ plus vector QR is equal to vector PR. Okay, so if we know the vector quantities, we can actually add them, and that's it, and you would find what that vector one is there. So we usually want to put them into triangles if we can. Other shapes will work as well, but normally we're doing triangles. But always the sum of all the vectors ends up being, the tail of the starting point to the tip, of the arrow of the ending point. So here are some examples for you drawn on the side here. But let's do an example ourselves. So here it says, given A and B as shown, construct A plus B. Now this is a bit tricky because I can't draw it exactly as is, but let's say that's A there. I'm going to do the squiggly A, so it's a vector. I'm going to pretend I'm going to grab this B and put it there. Okay, so I'm going to grab it and then move it over here so that it's stuck there. So let's just say my B is now there. Mine's not going to be exact, but let's say that's it. Okay, so the resulting vector, A plus B, I'll change to green, is you start at the tail of the beginning and at the tip of the end part, and so that there is A plus B. Vector A plus vector B. Okay, that's it. Very straightforward. The zero vector is a vector of length 0. So if I have, for example, vector A plus 0 is the same as 0 plus vector A, which is just A. But also if I have vector A plus the negative vector A, because it's say, being at a starting point, going there, and then walking back again, you're back where you started, so it's 0. It sort of cancels each other out. But if we're writing the 0 vector by hand, we usually write 0 with this little vector symbol on top of it. Okay, so let's do this example here together. It says find a single vector which is equal to BC. Let's see, so BC is here, vector BC plus vector CA. So CA is there. So you can see the one that actually adds up, if you start from, remember the tail, and you end up at the tip of the end point, it is actually going to be BA. So this one is BA. Okay, does that make sense? Next one, let me maybe rub this out and then I'll change colors. So now we've got vector BA, so B to A, plus A to E is there, plus E to C. So E to C is that one there. And let's have a look. What you've got to do is, again, start at the tail end of where you started, and you've got to end at the tip of the arrow that you end with. So it's actually just from here to here, even though that looks strange. It is equal to vector BC. Okay, and then the next one, I'm going to rub that out. We've got vector AB, so going in this direction, A to B, and then plus B to C, then plus C to A. We actually end where we started, so this one is actually the 0 vector. Okay, because it's like just going from A to A again, so it's just 0. And then the last one, where we got vector AB plus B to C plus C to D plus D to E. So clearly you can see we start at A, end at E, so this is vector AE. Okay, so that's exercise 12B.1. Let me just write this here for you. So please have a go. That is in your textbook on page 281. But while we're at it, let's do the next one as well. So the next one is geometric vector subtraction. So if we want to subtract one vector from another, we just add its negative. So A minus B is the same as saying A plus negative B. So you can see here I've got A, and then you've got vector B going this way. But if I want to subtract it, I just reverse the direction. So now it's going this way. Okay, so negative B, and then you add that together. So you can add yellow plus green there. It's still going to end up with pink here, but it's like A plus negative B, so it's just A negative B, A minus B. So if I have a look at this example, number 3, vector R, S, T, R, S, and T are shown. Find geometrically what's R minus S. Okay, so this is going to be a little bit tricky to draw. So let's say I've got, in question, maybe should have left more space. Let's say I've got R's like that. At the moment, S is kind of like that, if I stuck it on, but I want minus S, so that means I want it this way. So you can see then your final is going to be this. That there is R minus S, and I should put my squiggle on top. Okay, and then let's have a go at B. Okay, we've got S and then minus T and minus R. Let me just move this down actually, so we've got a bit more space. So if I redraw this, so if I have S is like that, now we want minus T. So at the moment T, let's see, at the moment T is kind of going like, hang on, T is kind of going like that, but I want minus T, so we're going to reverse it the other way, so it's going to go like that. Does that make sense? Yeah, I've just switched the direction. And then we've got minus R. Now R is currently going that way to the right, so I want to reverse it, so I want it to go the other way. So actually I'm going to move this other way so it won't fit. So we've got minus T, so R is now going to go that way because that's minus R. Yeah, so now we can see we just have to go from starting end or tail end to the tip of the arrowhead. So this here is S minus T minus R. Okay, the orange one. That's the resultant vector. And then example 4. It says for points A, B, C, and D, simplify the following vector expressions. Okay, so if I've got AB minus CB, I think we're going to have to draw this out. I'm sorry, I'm just going to move all this down. Hang on a minute. Let me move all of this. Okay, good. So then we've got, let's have a look. What have we got? We've got A to B, so let's say that's A, B. and then there's a CB somewhere. So let's say there's a C here. Normally, you know, BC would be this way, but we're going to subtract CB. So that means it's going to have to be this way, right? Subtracting CB would be the same as negative BC, so it's going like that. So that must mean your resulting one, I think, would have to be from there to there. Well, that minus that must be that one there, which is vector AC. Now, I couldn't do it the other way because can you see here, see how the two heads end up together here? So that's what made me go, okay, well, that one of those has to be like the resulting one. So it makes sense to put it from A to C, because then you're lining up, you know, tail to tip, and then, yeah, tail to tip. And then it goes from, you know, this tail at A to this tip at B. So that's it. So AB, vector AB minus vector CB is equal to vector AC. So you do need a lot of visualization skills here. You need to sort of be able to see what you're doing and use your imagination a little bit. If it helps, we can do the working out as like, you know, vector AB minus CB is the same as AB plus BC. Okay, if it was going from B to C, but we have to reverse the BC. Okay, but then we go, but vector BC is the same as negative of CB. Right, so therefore we get our solution that equals vector AC. And then in question B, last example, I think we'll stop there. I'll do the next one in the next video. Let's see, we've got A to C, so let's say this is AC here, minus BC. So let's just say B is there, because BC would be going the other way, so going from C to B is like negative BC. Yeah, that makes sense. And then we go from B to it's like negative dB, so that's like say D is there. Yeah, because from D to B would be going the other direction, so negative dB is going that way towards the left. Yep, that's good. And then you'd have, so then you just start from your tail end and at your tip, right? So you can see it's going to be vector AD. Does that make sense? So if you want to write it out, I'll do some working to help you. I'm more visual. I sort of just see it visually and sort of follow along, but still helpful to write this out. So you can see I've got, you know, AC. Then when you do negative BC, that's going to be the same as like plus CB, right? So negative BC is the same as plus CB, going this way, right? Plus CB, but we're saying it's the same as negative BC. The way we've put the B and the C makes that true. And then we've got plus, you know, BD, vector BD, but that is equal to negative dB. Okay, does that make sense? So we're going from B to D there. That's the same as negative going the other direction. Yeah, negative and negative. So that's what gives you that one. And we can see the resulting vector, the end one, is vector AD. Okay, so this one, guys, please have a go at. I'll write it here for you. You need to do exercise 12B.2, and that is on page 282 of your textbook. Please have a go, and don't forget to also do extra questions from the Oxford textbook, which is on your Schoology page.